let's have a look at annualizing interest rates, and what does that even mean? Or as we've also got written there, comparison rates. So to summarize all of this here, so imagine test scores, and that they might have different totals, and we want to convert them to a percentage. So for example, if you do a science test out of 47 marks and you do a maths test out of 58 marks and you got the score of 40 on each of them, which one's better? You could probably already guess, but a way of comparing them is to convert them each to a percentage and therefore see which one is higher. So that's probably a scenario that you're already quite familiar with doing. And so we're going to be doing that with interest rates too. So with interest rates, they're compounded differently. When they're compounded differently, that can be hard to compare them. For example, if one's compounded monthly or daily or weekly and they have a different rate, you want to try and work out which one's the best deal. And so that's what we're going to do in this concept here in this video. And there's actually laws against this. So the Consumer Protection Law makes it compulsory that the banks need to quote they'll either call it an annualized rate or a comparison rate when a contract is made. Another scenario you may have come across is when you go to the supermarket. It's sort of a similar idea. It's called unit pricing. Let's say you were to buy a small block of chocolate or a larger block of chocolate. If you have a look on the ticket on the shelf there, it will describe at the bottom usually what is called unit pricing. And it's usually done, say, per 100 grams. So it will show you the cost that it would be for each 100 grams for the smaller bar and the larger bar. And then you can compare to see which is a better deal, the comparison price between the two. So that's a similar idea. Check it out next time you're at the supermarket. And that's what we're going to do with interest rates here too. Last note here that it's the interest rate is if it was compounded once each year. So like that unit pricing, that's per each 100 grams, we're creating an annualized rate, imagining that each of those rates were compounded once per year, even though if what they're pitching it to you, the banks, and they're selling it to you as, is not that. To compare them, we have to make them compounded once each year. Okay, so have your graphics calculators handy. These videos make much more sense if you play along with me at home. So you've got your calculator there. We're using the financial menu, or if you're on an older version, it's called the TVM menu. And then we're going to use F5 this time and go into conversion. And you'll see just a couple of numbers sitting there, just an N and an I. Now the N, not the number of years, it's the number of compounds per year. So if it was monthly, it would be 12, twice a year or biannually, 2, quarterly, 4, those sorts of numbers. And then I is the nominal rate per annum. So that's the I that's given in the question or in the bank that you're trying to work out and to annualize. So just be prepared to flip between words such as annualize and effective rate. We're essentially working out the same sort of thing there. So let's just do one quick example on that. If you're asked which is the better investment rate offered between these two, 5.4% but compounded half yearly, or 5.3 compounded quarterly. So first of all, you might go, oh, 5.4, it's a higher percent of interest rate. That's probably better. Quarterly, how many times a year will that happen? 4. And half yearly, how often will that happen? Twice a year. So traditionally, when you compound more often, that's better, but it's a lower rate. So let's annualize this and find out the effective rate. So on your calculator, you need to put in the N and the I. The N is the number of compounds, so we're going to put in a 2 there. And then the I is the 5.4, just as 5.4, not 0.054. Hit the button for the effective rate, and I would go to 3 decimal places. It comes up as 5.473. So that's its annualized rate. So it's a little bit higher than just 5.4. What about the second one then? What's our N? Compounded quarterly, so that's 4. The I, the rate, is 5.3. Choosing the effective rate there. Oops, I've jumped ahead of myself there. And it's 5.406, I believe. Which one is higher? The first one was in the end. So the better investment then was the 5.4 compounded half yearly. That gives the highest effective rate. So and this time round, even though this one was compounded more often, it didn't actually make that much more difference. Yeah, so there we go. Just one more thing to consider is that fees and other conditions might come into play. For example, setting up the loan or the investment with the bank might incur some fees, or they might have other restrictions about certain deposits that you need to make as well, or something like that. So you'd have to take all of those into account to get a truly effective rate there. There are some questions to do now. Thanks for joining me.